Good morning, all. I welcome you for the lecture series in the course Material Science and Metallurgy. In the chapter Ferrous and Non-Ferrous Metals, we have discussed different metals, and we are going to see what is copper alloy today. So the introduction part to copper alloys, it is a versatility is enhanced through alloying. We introduce copper alloys and explore why pure copper is enhanced for superior strength, corrosion resistance, and wear resistance. In the olden days, we have been using copper alloys instead of stainless steel. The major groups include brasses, bronze, and cupronickel. Brass is an electrical connectors and plumbing fittings due to its excellent conductivity and corrosion resistance. So in the plumbing, we use copper taps, copper pipes because it is prone to oxidation and corrosion. So why is copper typically alloyed? So we have to increase its electrical conductivity, to improve its aesthetical appeal, to enhance strength, corrosion and wear resistance, to lower its melting point. So this is the four options given, and the answer is to enhance strength, corrosion and wear resistance is the answer, which we have seen in the previous discussion. So what are the limitations of pure copper? So anything which is pure, we cannot use it. As you all know, the pure gold is not used because of low ductility, and we have some copper inside. Likewise, pure copper is an excellent conductor. It has inherent limitations in certain engineering applications. So low strength pure copper is relatively soft and easily deformed. Pure wear resistance, we have wear down quickly under abrasive or frictional conditions. So imagine a mechanical component under a constant load. Pure copper would deform easily, leading to mechanical failure. So this highlights the need for alloys in high stress applications. So coming to the definition of the copper, these are all the metallic substances formed by the combining copper with one or more other elements. So when we combine with zinc, we get brass, and we combine with tin, aluminium and silicon, we get bronze, and when we combine with nickel, we get cupronickel. These are all three major forms of copper alloys. So engineering considerations for alloy selection is the major purpose of choosing copper alloy is strength, corrosion resistance and electrical conductivity. So for example, cupronickel alloys are specifically chosen for marine heat exchangers due to their exceptional resistance to seawater corrosion and biofouling. So alloying and processing methods, we have casting process, we have cold working, we have heat treatment process. So pouring molten metal into a mold to form a desired shape is often the first step for many components. And cold working, deforming the metal below its recrystallization temperature to increase strength and hardness. And heat treatment, controlled heating and cooling to alter microstructural properties like ductility and toughness. So here we have an MCQ. Which processing method primarily increases the strength and hardness of the copper alloys by deforming them before their recrystallization temperature? So before recrystallization always goes to cold working. It's a very simple question you can answer. And the testing methods are usually it is tested for its strength and ductility and hardness and corrosion resistance. So coming to the major properties, it has good machinability, high wear resistance and excellent corrosion resistance. So these properties are often repeated because the copper plays a major role for this requirement. So diverse engineering applications, because of its high conductivity, it is used in electrical and electronic components like PCBs, large scale integrated circuits and very large scale integrated circuits. Marine hardware, we use corrosion resistance in seawater and high wear resistance and low friction. Bronze bearings are extensively used in heavy machinery. So let us come to the small mind map of the copper from the ore to the extraction, physical properties and chemical properties and uses. So the ores are copper pyrites, glans, cuprite, ruby copper, and the extraction method is concentration of ore, roasting, smelting, bismerization, refining. And the physical properties are reddish brown metal, high leisure density, melting point. Chemical properties of action of air, heat, acids, chlorine, alkalis, and it is the applications are being discussed extensively in the previous things. So I hope you understood what is copper and what is the importance of copper, how we use copper in our day-to-day life. With this topic, we'll end this lecture and we'll see some other interesting topic in the next lecture. Thank you.